Hello, my name is Ricardo Vega, and today we'll be discussing the General Chemistry 1 concept of density. Now, density is an intensive property, meaning that the value of it won't vary too much, whether you have a different size or amount of the product. So today, we'll be taking the density of a dye, and I'll begin by putting it on my scale here. 5.6 grams. All right, and then I have some calipers here measuring in millimeters. So I'm going to take the length, width, and height of it. All right, and now using the volume of a cube formula, which is length times width times height, I am going to calculate the density or the volume of this cube. And now, because it's in millimeters cubed, I have to convert it to centimeters cubed. That way we can compare it later on in this experiment when we use the water displacement method to calculate the density again for the dye. So I'm going to go ahead and convert this to centimeters cubed. All right, so I went ahead and did the calculation, and I had my mass of 5.6 with the volume of 4.15 centimeters cubed. Divided that, and I got 1.35 grams per centimeters cubed. And now I have this graduated cylinder with 25 milliliters of water in it. And now I'm going to put this in there and take the final, or record the final volume. All right, so looking at this graduated cylinder now, after putting in the dye, it looks like it went up to 29 milliliters. So now we're going to take 29 milliliters and subtract it from 25 because that's the initial volume. And we get 4 milliliters. And now plugging that into mass divided by volume, which is the formula for density, using the same mass, we get 1.4 grams per milliliter. I'll show you the calculation here. Here again, which is using the calipers and the scale, we had the 5.6 grams, had the volume, converted it to centimeters cubed, put that into the formula, and got 1.35 grams per centimeters cubed. Here we had the water displacement method, which is 29 minus 25, had 4 milliliters, and then plugging it back into the formula, we got 1.4 grams per milliliter. And now, as you can see, these values are pretty similar, further proving the point that density is in fact an intensive property.